This is the second to last example from the 5.3.1 notes from in class. So solve each equation. Some answers may be imaginary. We're given the equation x squared over 3 plus 5 over 4 equals 0. So we need to, first of all, let's just get rid of those fractions. Let's multiply by 12 on each side because 12 is divisible by 3 and 4. So we're going to end up with 4x squared plus 12 divided by 4 is 3 times 5 is 15 equals 0. And to solve it, let's just go ahead here and let's isolate our x. I'm going to subtract 15 from each side. We have 4x squared equals negative 15. Then after dividing by 4, we have x squared is equal to negative 15 fourths. Now, just like we normally would, even though there's a negative on the right side, we're going to go ahead and just take the square root. We should end up there having our absolute value of x equals the square root of negative 15 fourths. So we know then here, and I'm going to move it up to the right side here, x is going to equal a positive or negative, right? And we have right now the square root of negative 15 fourths. But just like with multiplication, we can take each part and give it its own radical. So we'll just say this is like positive or negative square root of negative 15 over 4. I'm sorry, the square root of 4. Okay, so by giving them each their own radical, in this one here, I know that 4 is a perfect square, so I can make that into 2 in my denominator, and I still have the square root of negative 15 on the top. So the square root of negative 15, we still need to pull out our I, and we're going to have then positive or negative I times the square root of 15 over 2. And those would be our answers. Let's move on to the last one. The last one says x times the quantity of x minus 6 equals negative 13. Okay, normally we want our left side factored, but that's when it's equal to 0. So let's go ahead and simplify the left side by distributing our x through. So we have x squared minus 6x equals negative 13. And let's go ahead and set it equal to 0 by adding 13 to each side. So now that it equals 0, we can take it here and see if it factors. Well, we're not going to have any factors of 13, right, that have a sum of negative 6. So let's say it doesn't factor. You have several options now. You could either complete the square, use the quadratic formula. So I think you're probably going to be most interested in using the quadratic formula. So let's go ahead and use it. Remember, it is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So with our equation, we've got a is going to equal 1, b equals negative 6, and c equals 13. So let's plug those values in and simplify it down. X equals the opposite of negative 6 plus or minus the square root of negative 6 squared minus 4 times 1 and times 13. And it's all over 2 times 1. So that end up being 6 plus or minus, and then inside the square root, we should have a 36 minus, what is that, 52? And as we go through and simplify that part of it there, that should give us a 6 plus or minus the square root of negative 16 all over 2. Well, now, instead of saying no solutions, we have the ability to take the square root of negative 16, and we know that this is going to be 6 plus or minus 4i all over 2. And just like we've been doing here, now that we have a monomial in the bottom, we can give each part of it its own denominator. So we've got 6 halves plus or minus 4 over 2i. And then you can just reduce that last step, and we'll end up with 3 plus or minus 2i. And that ends up being our answer. That's what x equals. Okay, so normally, when we graph this doesn't touch the x-axis, so we wouldn't be able to come up with the solutions that way because we have our answers contain imaginary numbers there in them, which makes them complex numbers, and we'll talk about that tomorrow. All right, hopefully this helps you. If you had questions about this, we didn't actually get a chance to do it in class, so thanks for watching.